Welcome to a journey that challenges everything you know about cybersecurity. Today, we step beyond the boundaries of traditional IT and enter a world where quantum mechanics and philosophy intersect. Imagine a security system not built on brute strength but on the very nature of reality itself. This is the dawn of quantum cybersecurity, a field that redefines what it means to protect information. In this video, we'll explore how ancient wisdom, modern science, and bold imagination converge to create a new digital defense. Let's begin by looking at security through an unexpected prism. To truly grasp quantum cybersecurity, we must break away from the purely it-centric mindset. Think of a prism, an object that refracts light, revealing hidden colors. Similarly, quantum security refracts our understanding of protection. It's not just about firewalls or passwords, it's about how we perceive and interact with information. By blending quantum mechanics with the philosophy of perception and even the history of ancient seals, we open up new ways to think about digital safety. This interdisciplinary approach is the first step in our cognitive insurrection. Let's draw an analogy from history. In ancient Mesopotamia, clay seals protected messages, and in later times, invisible ink concealed secrets. These methods didn't rely on being unbreakable, instead they depended on the act of revealing. If someone tried to tamper with a clay seal, the evidence was clear. If invisible ink was exposed to light, the message vanished. Quantum security is similar. It's not about building an impenetrable wall, but about making the act of observation itself the trigger for defense. In our everyday world, observing an object doesn't change it. You can look at a locked safe and it remains untouched. But in the quantum world, observation is not passive. To observe is to act. The very act of looking at a quantum system alters its state. This philosophical shift is at the heart of quantum cybersecurity. It means that any attempt to intercept or eavesdrop on quantum-protected information leaves an indelible mark, alerting both sender and receiver. Traditional cybersecurity is built on the idea that to be secure, you must be stronger than your attacker. Firewalls, complex encryption, and multi-factor authentication are all about building higher walls and stronger locks. But what if security didn't depend on strength at all? Quantum cybersecurity overturns this conventional wisdom. It's not about being unbreakable, it's about being unobservable. The mere presence of an intruder triggers the defense, making the act of attack self-defeating. Quantum security's power lies in the intrinsic fragility of information. Unlike a fortress which can be battered and breached, quantum information is so delicate that any attempt to observe or copy it destroys its original state. This means that attackers can't even look at the data without causing it to change or disappear. The system doesn't need to be stronger than the attacker. It just needs to be sensitive enough to detect any intrusion. In quantum cybersecurity, the attacker becomes their own worst enemy. By simply trying to access the information, they trigger the very mechanism that destroys or alters it. This paradox means that the act of attack is also the act of defense. The system doesn't just repel intruders, it uses their curiosity against them. This is a radical departure from traditional security models and a cornerstone of quantum protection. Now let's dive into the quantum concepts that make this possible. Superposition is the idea that a quantum bit or qubit can exist in multiple states at once, not just 0 or 1 but a blend of both. Imagine information as a dancer moving gracefully between possibilities. As long as no one is watching, the dance continues undisturbed. But the moment someone tries to observe, the dance ends, and the information collapses into a single definite state. Another key concept is entanglement. When two qubits become entangled, their states are linked, no matter how far apart they are. Change one and the other changes instantly. This mysterious connection allows for secure communication channels. If an eavesdropper tries to intercept the message, the entanglement is disturbed and both parties know immediately. It's as if two dancers separated by continents still move in perfect harmony, unless someone tries to cut in. In quantum mechanics, the wave function describes all possible states of a system. When someone observes the system, the wave function collapses into a single outcome. In quantum cybersecurity, this means that the secret remains safe as long as it's unobserved. But if a spy tries to peek, the information transforms and the act of spying is immediately detected. The system is not just protected, it is fundamentally altered by the act of observation. Quantum cybersecurity shifts the focus from protecting data to redefining what protection means. It's not just about keeping secrets hidden, it's about making secrets fundamentally unstealable. The act of trying to steal information becomes self-defeating. This new paradigm challenges us to rethink our entire approach to digital defense, moving from walls and locks to the very fabric of reality. One practical application of quantum cybersecurity is quantum key distribution, QKD. QKD uses the principles of quantum mechanics to securely share encryption keys between parties. If anyone tries to intercept the key, the act of observation alters the quantum state, revealing the intrusion. This makes QKD the gold standard for secure communication in the quantum age. In classical systems, eavesdroppers can sometimes listen in without being detected. Quantum systems change the game. Any attempt to intercept quantum communication leaves a trace. The sender and receiver are immediately aware of the intrusion, allowing them to discard compromised keys and maintain security. This is a fundamental shift in the balance of power between defenders and attackers. Quantum mechanics is inherently random. This randomness is a powerful tool for cybersecurity. Quantum random number generators produce truly unpredictable numbers which are essential for creating secure encryption keys. Unlike classical random number generators which can be predicted or reproduced, quantum randomness is fundamentally unhackable. Let's return to philosophy. In the quantum world, perception is action. This challenges our everyday assumptions about knowledge and reality. In cybersecurity, it means that knowing a secret is inseparable from changing it. This philosophical insight is not just abstract, it has real practical consequences for how we design and understand secure systems. History teaches us that the best security is not always the strongest, but the most clever. Ancient seals and invisible ink relied on the principle that tampering leaves evidence. Quantum keys take this idea to the next level, ensuring that any attempt to intercept or copy information is not just detected, but fundamentally alters the information itself. Let's compare quantum and classical security. Classical systems rely on mathematical complexity, making it hard for attackers to guess passwords or decrypt messages. Quantum systems, on the other hand, rely on the laws of physics. No amount of computing power can overcome the fundamental limits imposed by quantum mechanics. This makes quantum security not just stronger but categorically different. Quantum cryptography is already being used in some of the world's most sensitive communications. Banks, governments, and research institutions are experimenting with quantum networks that promise unprecedented security. These systems are still in their infancy, but they represent the future of digital protection, a future where secrets are safe not because of secrecy, but because of science. No system is perfect, and quantum security has its own challenges. Quantum devices are sensitive and expensive. They require careful handling and specialized infrastructure, but as technology advances, these barriers are falling. The promise of unbreakable security is driving rapid innovation, and the quantum revolution is just beginning. Quantum networks connect quantum devices across distances, enabling secure communication on a global scale. These networks use entangled photons to transmit information, making eavesdropping impossible without detection. As quantum networks expand, they will form the backbone of the next generation of secure digital infrastructure. While quantum computers threaten to break many classical encryption schemes, quantum-safe algorithms are being developed to resist these attacks. These algorithms use mathematical problems that are hard for both classical and quantum computers, ensuring that our data remains secure even as quantum technology advances. Authentication is another area transformed by quantum technology. Quantum authentication protocols use the unique properties of quantum states to verify identities. Any attempt to forge or copy a quantum credential destroys its validity, making impersonation virtually impossible. As more data moves to the cloud, quantum security will play a crucial role in protecting information stored and processed remotely. Quantum encryption can safeguard cloud data against both classical and quantum attacks, ensuring privacy and integrity in the digital age. The Internet of Things, IoT, connects billions of devices, creating new security challenges. Quantum security can protect IoT devices from hacking and unauthorized access, making smart homes, cities, and industries safer and more resilient. Financial institutions are prime targets for cyberattacks. Quantum security offers banks and financial services a way to protect transactions, customer data, and communications from even the most advanced threats. The future of finance will be built on quantum-safe foundations. Healthcare data is among the most sensitive information in the world. Quantum security can ensure that patient records, medical research, and communications remain confidential and tamper-proof, protecting both privacy and public health. Governments around the world are investing in quantum security to protect national secrets, critical infrastructure, and public services. Quantum technologies offer a new level of assurance against espionage and cyber warfare, safeguarding the foundations of society. As quantum technology matures, its impact on cybersecurity will only grow. We are entering an era where the boundaries between science and security blur, and where the act of observation itself becomes the ultimate defense. The future belongs to those who can harness the power of quantum mechanics to protect what matters most. This journey has been more than a lesson in technology, it's a cognitive insurrection. By challenging old assumptions and embracing new paradigms, we unlock the true potential of quantum cybersecurity. It's not just about tools and techniques, but about changing the way we think about information, trust, and reality itself. In summary, quantum cybersecurity represents a leap forward in our ability to protect information. By leveraging the unique properties of quantum mechanics, we create systems that are not just harder to break, but fundamentally impossible to compromise without detection. The future of security is not about building higher walls, but about understanding and harnessing the deepest laws of nature. Thank you for joining us on this journey through the quantum prism.